Assalamualaikum and good morning to all.
Waalaikumsalam, Doktor.
Waalaikumsalam.
Okay, so it's me. I will send a WhatsApp group to the group EMJ37504. Alright. I hope you all well. We have another next week before we have our 8th celebration or your midterm break. So before I proceed, I will like to explain to you again what we will need to what I would like to cover for today's class. Firstly, I need to finish whatever for the system modeling, and then after that, after finish on that part, I will continue to give you some briefing on the lab. Okay, on the lab session. Okay, before I proceed with the today's content, I would like to refresh you again or do some revision whatever we have learned on the last week. Okay. All right. So on last week, I can put it as a system modeling part 1. Okay. So this is the contents that I will cover throughout the semester for my part. This is not included with Dr. Sitemani's part. And then after that, I give you some examples. Okay, some examples for the electrical circuit, how to convert the electrical circuit to differential equation, and then finally to the state space form. And then after that, we go to the first example. This is the first order system. And then after that, I go to the second example. Okay, second example from electrical circuit to differential equation to state space. So this is also the first order system. So at the end, we get this kind of the state space equation. And then after finish on that, we go to the same electrical circuit. Okay. However, this is a second order system. So what's a second order system look like in the state space form? So you can see here how to convert everything here. So finally, this is the answer. Okay. The electrical circuit to differential equation to state space for the second order system. Then I proceed with you some exercise. So this is the answer for the exercise number 1. And then this is the answer for the exercise number 2. However, previously I uploaded the wrong answer scheme. So this is the correct one, the answer for this exercise question. For the how to solve it, I will upload in the Google Classroom. Okay, and then after that, I also already uploaded the updated lecture slide in the Google Classroom, so you can find from there. Okay, so done for the electrical circuit. So this week, I would like to continue this week, I would like to continue with still loading. Okay, this week I would like to continue with the system modeling to state space part 2. All right. So for the system modeling part 2, we do the same thing, okay, similar to the previous week. However, only the system is different. Previous week, we use electrical system, all right. However, in this week, I will proceed with the mechanical system with the some examples and exercises. Okay, so what we have concluded on the first lecture. So in this chapter, the student will learn about the state space structure. I believe you are now familiar with the state space structure, which is x dot equal to x plus du, y equal to cx plus du, and then what is the meaning of the A, B, C, D? The A, B, C, D are the matrices, okay? And then what is the x? X refer to the state variables vector, okay? X dot is the differential of the state vectors, okay, and then y refer to the output, okay, and then after that we go to the item number 2, do the modeling of the dynamic system, which is convert the system electrical and mechanical system to a state space form. On the last week we already complete with the electrical part, so this week we will continue with the part mechanical part, okay. So I believe we can settle everything in the second item by today. Next, we will continue with the signal flow graph or the state equation, and finally simulation on the model system on MATLAB simulating and so on. All right. So far, how is it? Do you find? Do you understand how the state space? How you want to convert or you obtain the state space equation? Maybe I would like to ask a few students here to get the response. Ahmad Bayhaki, what do you think? Do you understand the concept? How to convert from the system to the state space? Okay, Ahmad Bayhaki, what do you think about that? I just need to have some response from you regarding whatever we already learned starting from the first week. Afif, Aimaduddin. How is it, Afif? Okay, thank you.
Yes, doctor.
Okay, do you understand the concept? What is the procedure to convert from the state system to the state space? Afif. All right, noted, Bayhaki. How about you, Anis Amira? Do you clear with that?
Yes, doctor.
All right, okay. Edward Emmanuel. How is it, Edward?
Yes, doctor. Okay.
All right. Leong Zichong.
Yes, I feel
Okay.
okay, don't worry.
All right, thank you, Leong. Mohanad. Mohanad, Captain.
Yes, doctor. Clear.
Okay. Last two. Murad Muhammad.
Yeah, doctor.
Thank you, Murad. And finally, Nurin Amni.
Yes, doctor.
All right. Thank you for the response. Okay, so we will proceed with the our lecture today. Okay, so we focus on the item number 2, mechanical system to state space form. All right. So this is the what we need to cover for today. So this is the area that we want to cover. So this one last week. So this week from mechanical, and we convert to the differential equation, and finally obtain the state space. Okay, so according to solve or to obtain the state space equation for the mechanical system, okay, you need this table. Okay, this is the force velocity, force displacement, and impedance rational relationships for spring, damper, and mass. Mass, spring, and damper. For if you have the question ask you about the spring mass damper system, you need to use this table, okay, in order to answer the question. All right. So this is the formula. The formula that we want to use regarding to this table, I would like to ask. Um, Let me see. I need to log in with this one to ask the name. Meet. Join. I want to. Oh, I need to off the mic. Okay. I want to ask Suman. Okay, Suman. Suman. According to this table, which one you need to use? Either you want to use force velocity, or you will need to use force displacement or impedance in order to obtain the state space equation. Okay, Suman? Just give you some based on your understanding on the state space. What do you think? Either force velocity, this is number one. Force displacement is number two. And finally, impedance, number three. Ada tak Suman bagi jawapan? Force displacement. Okay, thank you so much. That's the correct answer. So you understand that if you want to derive the state space, you need to refer the force displacement things here, because you can see that this is only the part we have the derivative. This one have integration. We don't want to use that. We want to use everything that have the derivative. Okay, next. If you have this system, okay, spring mass damper, you must know what is the input and what is the output. Okay. I believe for the mechanical system, it won't tell you which one is input, which one is output. You must know by yourself automatically what is the input, what is the output based on the spring mass damper. Okay, this is the crucial part. If you cannot determine the input or output of the system, I believe you cannot solve the question. So you understand. Okay. So I would like to call Beh Junho. Okay, Beh Junho. According to this spring, okay, according to the spring, okay, you have a few parameters here. You have K, you have FT, you have XT. I give you this small scope. Can you determine between these three parameters which one is the input? Beh Junho.
FT is the input.
FT. Okay, so it's actually FT refer to what?
Force.
Yeah, that's correct. Okay, you give the force. Okay, you give the force to the spring. Okay, and then you give the force to the spring and see how much the spring is moving. Is it?
Yes.
So, Azwan Farid, thank you, Beh Junho. Azwan Farid, what is the output based on the spring figure? Maybe Faiz Najwan. Okay, Faiz Najwan, what is the output based on the spring figure? Oh, you already answered in the chat. Okay, XT, that's correct. So normally, Azwan Farid also answer XT, that's correct. Okay, I just read your answer. So actually, XT refer to what? What parameter? What is the name of the XT actually? Anyone can answer.
Disbursement.
Total of force.
Displacement, that's correct. So it means that this is the current location of the spring. Let's say this is the current of the spring. So it means that the spring must always stay like this. Okay, must always stay like this. However, if you give some force to the spring, you can see the spring is moving or strength of in maybe millimeter or meter. Okay, how many if moving? That we call the displacement from the current location and move to the new location. And this is the correct the normal length. And however, when you put the force, it change. The length is changing. So how many changing from the normal to the current length we call as the xt, or we call as a displacement. Okay, displacement. Okay. So based on that, this is the force. Okay. If you give some force, this is how much the force value depend on the xt lah. Okay. And also depend on the k value. So you can see that this is xt. When you derive the xt, differentiate the xt, so it will give you what parameter? Anyone? If you have xt,
Velocity.
velocity, that's correct. So this is velocity and this is referred to the
Acceleration.
acceleration. Okay, so this is the connection between the xt, dxt over dt refer to the velocity, and d square xt over dt square refer to the acceleration. So now you are clear that when you have this kind of the question, you know that the force is the output, is the input, and then the displacement of the either spring or damper or mass, that we call as the output. All right. So similar to the mechanical system to differential equation to state space. So this is our second type of the mechanical system. I believe you know the answer. When you what is the things you need to use is the top angular displacement. Okay, top angular displacement. All right. So in this case, we look at the spring part. Spring part here. All right. So I would like to ask Koh Teng Sheng, which one is the input, Koh Teng Sheng, regarding to this spring?
TT.
TT, yeah. So normally, if FT is the force, and then the TT, what is the name of the parameter?
Top.
Torque. Okay. If anything that involved in the rotation, the input that we give to the any rotation, the name is torque. Okay. And then I believe if in the rotation, so it means that the changing of the current to the new position must be in the theta angle, is it? So the theta or angle is the output. So this is the thing that you must clear before you proceed to do the conversion from the mechanical system to the state space. Okay, so I believe you understand with that. Okay, so this is similar. If this is a theta, the angle, okay, how much angle change after you give the input to the system, the input is a torque. And then for the damper, this is the angular velocity here. And this is referred to the angular acceleration. Okay. So now we go to the first example. Okay, first example. So this is the spring mass damper. This is force because force only applied on the linear direction. Okay, so that's why we call the input as a force. All right. So the figure shows a spring mass damper system. Determine the order of the system. Okay. So how you want to determine the order of the system? And then the second question, obtain the state space of the system. Before we need to determine the order of the system, we must know we need to use this table in order to solve or to design or to convert our system to state space. Okay, so this is a spring mass damper. and we know that we need to use the force displacement formula. All right. Okay. So after that, we shortlisted the formula. Same procedure with the previous. Okay. After we shortlisted the formula, you look at that the spring. We have spring here, we have damper, and we have mass. And this is our target to obtain the state space equation x dot t equal to axt plus but and yt equal to cxt plus dut. Okay, I hope you will appreciate this thing when I do the demonstration on the Simulink later. Then you know, oh, this is the thing, give you what. Okay, I hope with that. Okay, so you have these three items here, M, K, and FV. So this is the thing. So how you want to determine the order of the system? So you know that the input is the FT force, and then the output is the XT. Yeah. The order of system is a second order system, since the highest derivative in the formula is 2. So for the mechanical system, you see that you look at how is the highest derivative in the shortlisted formula. So in this case, you can see the highest is d square xt over dt square. So it means that the order of the system is second of the system. All right. So I would like to ask Muhammad Khairunas, if your system, Khairunas, is second order system, what is the highest x dot you have? X dot is mean that in this case, you have x1 dot, x2 dot, x3 dot, x4 dot, x5 dot, is it? But now we already know that our system is second order. Okay, so what is the highest x dot we have for the answer, Kairunas?
S dot 2.
Yes, that's correct. So it means that you must expecting that your final answer only up to x dot 2. You won't have any x3 dot, no. You will not have x4 dot, no. You will not have only x1 dot, no. So if you get the answer, the final answer up to x2 dot, this means that your answer is probably correct or correct. All right. Okay. So that's why we must know what is the order of the system, since we can confirm with our answer. Okay. And then after that, we need to obtain the free body diagram for the system using Newton's law. Write the equation of motion. So this is the thing that you learn on the first previous semester. Okay. Uh, okay. So in this case, I need to show you something. This one, not this one. Okay. Alright. Mak jelas sekali pula dah. Escape. So I need to remove the animation for this one. Alright. So this is a question. Firstly, this is the location of the force. Location of the force. The force attached to the mass. Okay. So in order to do the free body diagram, what you need to do, you need to find any items that attach with the mass, because mass is the place where the force is given. The force is given at the mass. then you need to find whatever attached to the mass. So in this case, the things that attach to the mass is the spring and damper. So it means that if you give some force to the mass, the spring and damper also will be affected. Okay, it's not only mass only affected, so it means that the position of the mass, not only the mass, the position of mass not only change, however the position of the spring and damper also will be changed, because these two things are attached to the mass. So that's why you can see that mm, that's why you can see that for the mass here, the mass, the force and spring, the mass, the force and the spring are affected when you give the input to the system. If you give input to the system here, the affected things here is mass, spring and damper. Okay, so that's why this thing want to make sure it return back to the current position. That's the characteristic of the spring mass damper. They want to return to this its current position. So that's why if you give the mass here, so that's why the direction of the force for the spring, the damper, the direction of the damper, the direction of the force of the mass must be opposite, because this force want to return back to the current position. So this is how we come up with the free body diagram. Okay. So based on this, according to the Newton's law, we need to write this equation. The summation of the force equal to zero according to Newton's law. So this is force for the spring, this is force for the damper, this is force for the mass, and this is the force of the input. So that's why we get no, this one. Actually, this is referred to the F equal to F, right? So you can see that the force of the mass here plus with the force of the damper plus the force of the spring equal to the force of the input. How many of them? 1, 2, 3, 4. So that's why we have 1, 2, 3, and 4. So this is the Newton's law of the force. Okay, so based on the equation, so we need to replace the parameter according to the level that you learned on last week. So this is the parameter lah. You have here xt, dxt over dt, and d square xt over dt square. You have xt, dxt over dt, d square xt over dt. And then after that, we just name xt equal to x1t. Okay. And then after that, when we derive the x1t here, that's why we come x1 dot t. x1 dot t also we can name as the x2t. Okay. And the x2t, when we do the derivation up to x2 dot t. Okay. So I would like to ask Ari Mugen, why we did not replace here x2 dot t equal to x3? Okay, Ari Mugen, what is your answer? Why we just stop until x2 dot t? Why we did not replace up to x3t? So, Ari Mugen. Are you there, Ari Mugen? Just answer yes or no. Godri, what's your answer, Godri?
Because the maximum is x dot 2.
Yes, because you understand that the order of the system up to x2 dot x2 dot. So that's why we stop until x2 dot. We did not proceed with the x3. And then the other option that maybe you can remember, the highest is d square xt, this one, is it? So you just need to make sure this one. All right. Okay, so we do the replace the parameters according to the table. We know that this one refer to x2 dot t. dxt over dt, we need to choose x2t. We did not want to choose x1 dot t because in this equation, we just want to have only one x dot. We did in this the rest of the equation we only have xt. Okay, so in this case, that's why we have the x2 dot t. The rest we would just want to make sure only have xt only without the dots. So we have fv x2t plus k x1t equal to ft. Okay, and then we arrange everything and becomes x2 dot t equal to negative k over m x1t minus fv over m x2t plus 1 over m ft. All right. So done for x2 dot t. Okay, we have the maximum until x2 dot t. How about x1 dot t? So anyone would like to guess what is x1 dot t equal to? Muhammad Aizat bin Ibrahim. x1 dot t equal to what, Aizat?
X2?
Yes, that's correct. How do you get x1 dot t equal to x2, Aizat?
Based on the table, replacement parameter.
Yes, that's correct. So that's why this part of table is really important lah, in order for you to solve to obtain this one. So you get that x1 dot t equal to x2 t. All right. So done. So according to this thing that x1 dot t equal to x2 t, x2 dot t equal to negative k over m, x1 t minus this thing, right? And then we need to convert to the state space form. So we have s1 dot t, x2 t here. And then since s1 dot t only equal to x2 t, so that's why here becomes 0 and 1, because 0 multiplied with x1 t becomes 0, plus with 1 multiplied with the x2 and become x2 t, plus with 0 multiplied ft will be 0. So here will be x1 dot t equal to x2 t. All right. And then for the x2 t part, x1t equal to negative k over m. Yeah, negative k over m multiplied the x1t plus with negative fv over m multiplied with the x2t plus with 1 over m multiplied with the ft. So this is how we want to convert from these two equations to a state space form. All right. And then from the figure, we know that the output is xt. Yeah. As you already know that when before you answer the question, you must know what is the input and the output. The output is xt. So from the table, xt here equal to x1t. So that's why we got yt equal to x1t. So finally, this is our yt equation. Yt equal to 1 multiply x1t equal to x1t plus with 0 multiply with the x2t become 0. So that's why here we get the equivalent yt equal to x1t. Okay, so we already obtained the final form of the state space. This is for the x dot equal to ax plus bu. This is y equal to cx plus with du. So in this case, this is our A matrix. This is our B matrix. This is our C matrix plus D. Our D matrix equal to 0. Okay, so in conclusion, I can conclude that if you have the mechanical system, you want to convert to the state space. Firstly, you have the mechanical system here. you need to convert to the free body diagram. After that, you need to obtain the differential equation. And finally, based on the differential equation, you compute the state space equation. All right, so far, are you okay with the first example?
Okay, Doctor.
All right, yeah, thank you. So now we go to the second example. Mechanical system to differential equation to state space. So example 2, the figure shows us if this is not spring mass damper. This is we call the initial spring initial damper. Until that, I need to check what is the correct name for the system. Okay. Okay, firstly, you need to determine what is the input. Nurul Farhanah Nasuha. What is the input Nurul Farhanah Nasuha? Oh, you answer in the chat box. Let me check chat. Okay, I just read your answer by Haki. Alright. Okay, Nurul Farhana Nasuha, what is the input for this question? Okay. Lavanya, what is the input Lavanya?
Doktor,
Ini Nurul Farhana ke?
tak Doktor.
Talk
Titi
Titi. Yeah, that's correct. Okay, thank you for the answer. So the input is a talk Nurul Farhana. Okay, so Lavanya, what is the output, Lavanya? What is the output based on this figure?
The theta.
Okay, can you name? Because there are two thetas here. So which theta? Lavanya?
Theta 1 and theta 1
Theta 1. Do you have any output do you like to add, Lavanya?
and theta 2.
Yes, that's correct. So in this case, you can see that there are two outputs here. Theta 1 and also theta 2. Okay, so previously we just see only one output. However, in this example, you can see there are two outputs here. You have only one input, however, you have two outputs. So we can call this system is single input, multiple output. We call SIMO, single input, multiple outputs. Okay, so this is really important lah. Before you proceed to answer the question. Okay, so firstly, you need to determine the order of the system. The order of the system. So you know that according to this question, you need to use this table in order to obtain the state space equation. Okay. All right. So you can see that I forget to do the shortlisted equation. So what do you think? Determine the order of the system. So what is the order of the system? I would like to ask. Osama Muhammad. So what is the order of the system, Osama? Oh, Tanjiaji, you would like to have Tanjiaji, Osama and Tanjiaji. What is the order of the system?
Hello.
Yes, if this is Tanjiaji, yeah?
Yes.
Okay, what is the order?
Second order.
Second order, do you like to change your answer, Tanjaji?
Uh, no.
Okay, all right. Second order, some also as second order. However, I would like to tell you that this is not a second order system. Okay, anyone would like to guess what is the order of system?
First.
First order. Okay, let's see. And Mio, Muhammad Firdaus, and Melvin. Mio and Melvin. So, what do you think about the order of system? Let me see in the chat box. Is it you give an answer in the chat box? Okay, Mio.
Apa tadi doktor? Saya kat toilet.
What is the order of the system for this question, Mio? The wrong answer is second order. So, what do you think?
First order.
This first order.
Mhm.
First order. Okay, Melvin. Melvin, first order. Okay. So Melvin also said the first order. However, the answer is, let me write the answer. The answer is, Allah Allah. Top order system. This is the answer. Let me to make it bigger. Plus. The answer is for the system. Okay. So as usual, what you need to know, how many or determine the order of the system. As usual, regarding to this thing, you need to do the shortlisted the formula. Okay. So I need to copy this one. Copy. I need to put it here. We need to do the shortlisted. I need to duplicate this one. Okay. I need to remove this thing. Shortlisted the formula. And then copy everything here. Control copy again. Put it back. Okay. So according to this table, the highest of the inertia, the highest derivative between these three subjects is the inertia, is it? Inertia. So when you look at that, okay, when you look at this question, you look at how many inertia do you have and outputs do you have. Okay, firstly, you have two outputs. Okay, so you have two outputs. So if you have two outputs, so you have, lemak tadi nak ubah okay, you have just listed the formula, you have the two outputs. So I need to insert the equation. You have theta 1 T, and then you have the other is control copy, what's that? Control copy, control V, you have theta 2T. Okay. At theta 1T region, the highest parameters or the subject is the J1. So it means that the highest here will be you have J1 okay d square theta 1 t over dt square. I need to make it bigger lah after this. Allah. T square. Okay. Control Z. For the first output. And then for the second output, theta 2t, okay, the highest is J also. However, in this case, they are J2. We have J2 d square theta 2 over dt. So you can see that this is the different theta. This is J1 refer to theta 1, J2 refer to theta 2. Before this, I mentioned you how you want to determine the order of the system. You look at the highest derivative in the shortlisted formula. So the highest is only d square xt over dt, only one. Only this is 2n. So that's why this is second order system. However, in this case, there are two outputs, theta 1 and theta 2. And then this is the highest for the theta 1. And this is the highest for the theta 2. So you can see that 2 plus 2 become 4 order of the system. So this is how you want to determine the order of the system. You look at the outputs, how many outputs there. If one, mostly you will get second order system, but now we have two outputs. Then we look at the highest parameter or subject in these things. Okay, we have the J2. So that's why we call it as a second order system. So example, we did not have this. Okay, let's say we didn't have J2. Okay, let's say example, you didn't have J2 lah. So however, you can see that for the output number 2, you only have K and D2 only. So you can see that the output number 2, the highest is D2. And then this is the D2 according to the table formula, only this thing. So what is the order of the system now? Okay, anyone who has a third order system, that's correct as well. Because let's see, in this second output, we only have spring and damper only. And then between these two damper give the highest derivative, which is d power of 1. So here we have 2 plus 1, then become third order of the system. Okay, so now we need to return back to the original question. I need to duplicate, duplicate this slide. Okay. Right. So now you know that this is fourth of the system. So when you have the fourth of the system, you can expect that your matrix or your state space will be up to x1 dot, x2 dot, x3 dot, x4 dot. You will not have x5, no. You only have up to x4 dots only. Okay. And you know already the input and output. Okay, so next, we already know our input and outputs. And then we know that the order of the system is a fourth order of system. So firstly, what you need to do, you need to convert the system to a free body diagram. Free body diagram. So you can see that this is the location of the outputs. The location of the outputs attached to J1 for theta 1, and then the location of the output of theta 2 attached to J2. Okay, so now we need to focus on theta 1 only first. Okay, we need to focus on theta 1 first. Look at whatever uh, things or parameter that attach to J1. So you can see that when J1, the parameters that attach to J1 are D1 and K. Okay, so the affected region at theta 1t direction, output direction, when you give input torque to the system, if you give torque to the system, the affected area that only involved by theta 1t direction, output direction, only these three parameters for this question, J1, D1, and K. Okay. So now we already know that this is the area that affected for the theta 1t. Okay, so next we look at the second output, theta 2t. The affected region, when you give input to the system, that changed according to the theta 2 direction is K, J2, and D2 because K and D2 attached to the J2. Okay, so you know that this is the region of the theta 1. This is the region of the theta 2, output theta 2. However, you can see that this is the overlap region, the only affected region at theta 1 and theta 2 direction when you give input to the system. I will explain to you what this thing mean. Okay. So now we want to focus this area, theta 1. Free body diagram. When we give the input to the system, look what happened or changed at this region first. Okay, when you look at this region, how many items that connected in this region? You have J1, you have D1, you have K, you have input TT, and then you have theta 1 T direction. So how many? 1, 2, 3, and 4. So you look at this area, you have 1, 2, 3, and 4. Okay. If you give the input at this direction, let's say counterclockwise, as I mentioned before, the system would like to maintain its original position. So that's why the torque, when you give the input here, the response of the torque for this system must be opposite to the input because it want to maintain its original position. So that's why the direction will be clockwise. If you give the input to counterclockwise, the reaction direction must be different, opposite. In this case, is clockwise. So that's why the direction of the J1 here, K also different, and also D1 also different, different from the input. Okay. So, however, according to the previous slide, the K, only K affected by theta 1 and theta 2. Okay, so that's why we need to also consider this K that also affected by theta 2. This thing already affected by theta 1. According to the previous slide, this is the overlap region. This region also will be affected to theta 2. So that's why we have this second free body diagram for the theta 2 here. Okay, So you can see that the direction here is similar to the torque input. Okay, so according to this free body diagram, we just come out with the equation lah. So you can see that we can choose any, but in this example, I choose clockwise direction positive, counterclockwise direction negative. So anything clockwise, J1, this one, plus with number 2 is this thing, number 2 plus with K theta 1t, okay. This is counterclockwise, that's why I put negative TT. This is counterclockwise, that's why I put negative K theta 2 T equal to 0. So that's why we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. Okay, so this is our first region here. Then we need to solve for the second region here. Okay, we do the same thing. How many items they attach in this region? You have 1, 2, 3 only. So you have only J. We didn't have any input in here. So that's why we only have 1, 2, 3, 1, 2, 3, and also the region. And then after that, we need to consider the spring that overlap before with the theta 1. So that's why you got this one, K theta 1T. Okay, and then after that, you come up with the Newton's equation. So this is number 1, number 2, number 3, and number 4. Number 4 being negative because it's at counterclockwise. And the rest it will be the rest are in clockwise. So finally, you got the first equation and second equation. Okay, this is the first region. The second refer to the second region. Okay, so after that, what we need to do, we need to know that this is we have theta 1, we have theta d theta 1 d square theta 1t over dt square. And then we have theta 2 d theta 2t over dt d square theta 2t over dt square. And then after that, we need to come up with a table. So you have theta 1t, you have d theta 1t over dt, you have the d square theta 1t over dt square. And then you have the theta 2, this theta 2t over dt, and finally d square theta 2t over dt square. And then you just do the replacement lah. Theta 1t equal to x1t. Okay, can you hear me?
Boleh.
Can doctor, can.
Yes,
Okay,
doctor.
I can see that my laptop lost the internet connection. So I need to check the internet connection first. Alright, so I need to wait a few minutes until my internet switch on again. Someone is switch off the internet, the router, so I need to wait a few minutes. Sorry for that. So the last thing that I explained stop until which one? Anyone remember?
The order table.
Oh, table replacement. Okay, alright.
Doctor. Doctor tak on mic.
Alright, thank you for letting me know. Okay, so proceed again. Okay, according to this table, since the first output, the highest is J1, so that's why we stop until x2.t. We did not process with x2.t equal to x3 because we just refer to first region. The green refer to the first region here. And then after that, the blue part here, we focus on the second region. The second region, the highest is J2. That's why we stop until x4.t. So for this table, we need to separate it between these two regions lah. So let's say in this case, if you have three outputs, you have theta 1, you have theta 2, and also you have theta 3. Yeah? The highest possible of the order of the system will be 6th order of the system. And then for this table, you will have three parts. This is the first part, second part, and then you have the third output, the third part. And then after that, you will stop until x6.t. So this is how we want to convert from this differential equation to the table. And after that, you do the replacement lah. Finally, you obtain that x2.t equal to this value for the first region. Okay, and then after that, we proceed with the same procedure with the second region, and then also we just need to replace the same table, just refer to the same table and obtain the x4 dot t, and this is the answer. And finally, this is for the x2 dot and x4 dot. So how about x1 dot t and x3 dot t? Because we only have x2 dot t and x4 dot t only. So to get x1 dot t and x3 dot t, as usual, we just need to refer to the table. In this case, x1 dot t equal to x2 t and x3 dot t equal to x4 t. So finally, after you obtain that, so this is x1 dot t, x2 dot t, x3 dot t, x4 dot t. So you convert to the state space form. You know that x1 dot t equal to x2. So x1 dot t equal to 0 multiplied with x1, 0. 1 multiplied with x2, x2. 0 multiplied with xt will be 0. 0 multiplied x4 is 0. 0 multiplied with the input tt, 0. So you can get that x1 dot t equal to x2 t only here. So similar to the x2t, this thing you have x1, x2, x3, and tt. So that's why you have the region of the x1, x2, x3, and also the tt. For the x3 dot t, you have only at the x4 part, 1, the rest is 0. And also for the x4 dot t, you have at the x1, x3, and x4. You have x1, x3, and also at the x4 part. And the rest are zeros. Okay, so according to the question, you know that you already determined that the output is theta 1t and theta 2t. Okay, the output is theta 1t and theta 2t. According to our table before, theta 1t equal to x1t, theta 2t equal to x3t. So that's why our output here, y1t equal to theta 1t, y output number 2 equal to theta 2t according to table. This is the equivalent for the theta 1 and theta 2. So when we convert to the state space form, so the output is 1, 0, 1, 0. Okay, x1 plus 0 plus 1, x2 plus 0. So this is the answer. Sorry, this is not correct. I need to change it back because we have two outputs, yeah. So this is not the answer. Tiga. Sorry. This is not the answer. Because we have two outputs. So this is referred to the output number 1. Output number 1, 1, 0, 0, 0, because y1 equal to x1t only. And the output number 2 equal to x3t. So that's why we have this kind of the answer for the output. So in conclusion, based on the system, when we want to convert to the state space form, so this is the answer. This is our A matrix. I need to change it to this one. Copy. Okay, apa benda ni? Dari sana. I'm not sure. So, okay, you have this answer. This is A matrix. This is X dot. This is A matrix. This is X. This is B. This is C, and X. Later on, it's really important for you to know what is your A matrix, B, C, and D, because you will use all the information for the further analysis. So in conclusion, okay. Okay. So far, how is it for the mechanical to the state space? Do you can follow? Syamil, Muhammad Syamil bin Muhammad Nabi.
Yes, yes, Doctor.
Alright, Azrul Naif, sorry, Azrul Hanif. Do you can follow Azrul Hanif? Kushon Wayne. Thank you, Azrul. Kushon Wayne. Kushen Wayne, sorry. You can follow.
Yes, doctor.
Okay. Then for the mechanical system, to differential equation to state space, the last part to do the modeling is converting the differential equation to state space. Okay. Actually, you already learned how to convert from the differential equation to state space. So you have this kind of the example. Let's say you have this kind of the differential equation and then you need to convert to the state space. So what you need to do, you need to replace the parameter into a table. So this is the flow. Let's say the question give you the differential equation, and after that you need to come up with the table, and after that you need to uh, obtain the state space equation. So done for the differential equation to state space. Okay, so here there is a few exercise. There are a few exercises for you. Firstly, you have this is the translational mechanical system here. Translational mechanical system. I hope you can try to solve this thing. So you can see that there are two outputs, x1 and x2. And the first output, the highest is m1. The second output, the highest is m2. Is it? And then after that, based on this information, you know that the highest is d square xt over dt. Okay. And then m2 also dx2 square t over dt. So that's why the answer is 4 order of the system. Okay. So in this case, similar. This is the output number one, theta 1t. However, in this question, it not label you the output number two, theta 2t. Actually, there is a theta 2t here. Okay, theta 2t here. So you need to know that there are two outputs. Automatically, there are two outputs regarding to this question. Okay, according to the question, there are two outputs. That's why the first output you have J1, the second output you have J2. That's why it become four order of the system. Okay, and then the last question, you can see that the highest derivative in this question is 3. You have x, x dot, x2 dots, and x3 dots. So that's why you have the highest is 3 dots. So that's why you got three order of the third order of the system. Okay, so this is how you want to. However, you can try to do the exercise and compare your answer with these answers. All right. So for you to do more exercise example, to find more exercise example, you can find more exercises example in this textbook. So you just click this link using your Unimaps email, and then after that you can refer to the textbook that I provided in this link in order for you to do more practices, examples, and exercises. All right, and then announcement. Lab 1 will be conducted on week 7 after the Eid celebration. Supposedly, I have booked a lab. Yesterday, I have booked a lab on for 28th of April. However, I tested positive COVID-19 this morning, so I can make it to the lab on the date. So that's why I have to postpone week lab on next week to week number 7 after the Eid celebration. Uh, so during the lab, anyone can come to the lab session, or you can do by your own at your hostel. It won't be any problem. So I just book a slot for you. So I will be there too. And let's say if you want to ask me anything regarding to the lab, also regarding to the subjects, just come over. So you can bring your laptop too, and then do the analysis or simulation using your laptop, no problem. And also you can use the facilities that have in the lab. Okay. And then the second announcement, quiz one will be held on Thursday, 20th of April 2020 at 3 p.m. So this is during the lab time, lab session on next week. Yeah. I will give you a Google Form link via WhatsApp group exactly at 3 p.m. Then you need to answer the quiz, which is in MCQs format. Please let me know if any lah. So let's say if you have your class is clash during this quiz one session, please let me know. All right. Okay. So I think done for the contents today. So we will break about 10 minutes. We before we can start with the some briefing how to run simulation using MATLAB. Okay. So see you at 11:25. If you have any question, you can ask me now. No problem with that. Yes, Leon. The time for the quiz is around 10 to 12 questions within 12 to 15 minutes. So I will write the answer too. So I need to stop the recording. Stop recording.